Welcome to the Fuel Pulse Show podcast. I am your host, Eric Bjornstad, and today I'll be your guide through the ever-changing world of fuel. This is a podcast for anyone who uses fuel or who has things that use fuel, whether that's at work or at home. And it's for both consumers. It's also especially for professional people who work in jobs and positions where one of the things that they may have to do is manage fuel so that that fuel can be used in some capacity to get the job done, whatever that is. And that means the Fuel Pulse Show podcast is for everybody. So, what are we going to talk about today? Well, today we want to talk about an update for hurricane season. Hurricane season typically covers the 6 months between June the 1st through November the 30th. And at time of this recording, we're coming up towards the end of August, and really the storm activity seems to have been pretty sparse. But as time goes on, when you go through a hurricane season, you gather more and more information, and that enables the meteorologists to make better predictions and enables them to refine their forecasts. And so, usually, they will come out with updates later in the season that take all of this new information into account. So, the first predictions for hurricane season actually will come out about the beginning of the year, and then they will get updated periodically throughout the year in the months that follows. But a prediction for in January for what's going to happen in September and October and November, that seems pretty early. And so what we like to do is we like to wait a little longer into the season to allow the data to bring the weather predictions into better focus, if you will. And so we don't tend to pay that much attention to the January predictions. The first ones that we do like to pay attention to are the ones that come out in April and mid to late May. And these predictions tend to come from several groups. First is the National Hurricane Center, which is part of the National Oceanic and Atmospheric Administration, otherwise known as NOAA. And the National Hurricane Center is really one of the most authoritative sources for Atlantic hurricane forecasts. So we pay a lot of attention to their forecasts and their predictions. Then you have the Tropical Meteorology Project from Colorado State University. This team has been making predictions since the 1980s, and their predictions are widely cited and very respected in the meteorological community. And then there are other academic groups like Penn State, North Carolina State. They also tend to issue respected hurricane season forecasts. And there are some European groups as well, like there's a group in the UK that does this. And so all of these groups together, they will chime in over the month of April and throughout May, and you'll get a body of pretty good predictions about what the most informed people think is going to happen during hurricane season. Now, one thing to keep in mind about hurricane season and the kinds of storms that are predicted in hurricane season is that they are not just hurricanes. The meteorologists are monitoring the formation of subtropical systems, and some of these subtropical systems will then develop, strengthen, and coalesce and develop into tropical systems. And then some of those will strengthen and coalesce into hurricanes and then even into major hurricanes. Now, while we haven't seen much activity so far in the year 2023, there has been some, just not really the onslaught of major hurricanes that might tend to grab our attention. The first tropical system for this year's Atlantic hurricane season actually formed in mid-January, which was the earliest that one of those had formed since 2016. But many tropical systems such as that one, they don't end up forming into tropical storms or larger. They tend they'll appear, but then they tend to fizzle out. And so far this year, there have been 6 tropical systems as of August that have strengthened and coalesced enough to form into actual tropical storms. However, all of those actually fizzled out before they reached the United States, at least until the latest one, which was Tropical Storm Harold, which became the first Atlantic storm to make U.S. landfall on August 21st at South Padre Island in Texas. But even then, it didn't turn out to be a significant storm event in the grand scheme of things. So even though the hurricane season officially starts in June, the first couple months of the Atlantic hurricane season, June and July, tend to be relatively quiet compared to the peak of the season, which is from August through October. And there are several reasons for this historical phenomenon. And you're going to hear more about the role of some of these reasons as we talk about the subject of how these storms form and what helps them form and strengthen versus what hinders that. So, uh, why are June and July the least active months of a typical hurricane season? Well, the first thing you have to look at is sea surface temperatures. See, hurricanes thrive on warm ocean waters. Typically, they do best when there's a sea surface temperature of at least 80 degrees Fahrenheit. And in the earliest months of the season, especially in June and early July, the waters in the Atlantic are often not sufficiently warm enough to support the development and intensification of tropical storms and hurricanes. Another thing that tends to be a characteristic of these months is wind shear. Now, you're going to hear that term a number of times as we talk about hurricane season, but that's because it's an important concept. The meteorological term wind shear, what it refers to is changes in wind speed and wind direction with altitude. Now, we say with altitude, what we mean by that is that you have to think of the atmosphere as a three-dimensional unit, a three-dimensional entity, and different things are going on at different altitudes. And so what you have wind all throughout the various altitudes. And these wind patterns, wind currents are moving in different directions. And sometimes you'll get what they call a strong wind shear, where the winds will actually move and change direction erratically, and they'll speed up and they'll slow down erratically. And when you have this kind of erratic wind behavior, that really inhibits the development and organization of tropical systems, which makes it difficult for tropical storms and hurricanes to form and get stronger and strengthen and eventually become the ones that we see. And for June and July, wind shear is often stronger in the earlier parts of the hurricane season. And so we don't tend to get as many storms in June and July. Earlier in the season, we also tend to see more stable air masses parked over the Atlantic Ocean. This prevents the formation of organized thunderstorms, which are really the seeds of the tropical storm and hurricane development. And also, in the early part of the months of June and July, during the earlier part of the season, the air also tends to be drier. Again, less moisture in the air means fewer storms forming. So, all of these factors together mean the weather conditions tend to be less favorable in June and July for the formation of hurricanes, and that's why those months are less active. Now, going back to these season forecasts, when we talked about the initial season forecasts, the ones that we paid attention to in April and May. Now, different groups made slightly different predictions, but the consensus was that, towards the end of May, the consensus was that they were predicting what they termed as a near normal hurricane season. Now, when they issue these predictions, they will usually give a prediction on the number of, first of all, named storms, second of all, the number of hurricanes, and then third, the number of major hurricanes. And that's what their predictions look like. So the prediction at the start of the 2023 Atlantic hurricane season was that we were going to have, remember, they said a near normal hurricane season. That means either normal or slightly below the typical amount of activity. So what they predicted was, first of all, named storms. between 12 and 17. Now, when we say named storms, remember, that doesn't just mean hurricanes, that also includes tropical storms. In fact, the majority of named storms are tropical storms. So 12 to 17 named storms, between 5 and 9 hurricanes for the season, and then between 1 and 4 major hurricanes. And those figures, 12 to 17, 5 to 9, 1 to 4, those figures are typical for an average hurricane season. So earlier in the year, they were thinking that the season was going to be pretty, relatively uneventful in terms of activity. Now the question is, and as we're later in the season, has anything changed in that respect? And we asked that question because, as we said at the very beginning, they make predictions at the start, and then as the months go on, more and more information is learned. They get more data, and they're able to take new things into account. And so sometimes that means that they are able to refine their predictions. And so what happened with this? So the groups like the NOAA, they're continuously monitoring and analyzing various meteorological and oceanic factors throughout the hurricane season. And then they will issue their revised predictions later in the year because they have this new information. And particularly, they're paying attention to a number of different things. They're going to look at the most recent data that they have on those sea surface temperatures. Remember those. They will monitor any changes in the temperature of the oceans. And that's pretty important. That's crucial because warmer waters provide the energy that's needed for hurricanes to form and strengthen. In fact, warmer waters or warm water is probably the most important factor in having an active hurricane season because that provides the fuel and the energy for these storms to form and strengthen. So they're going to look to see if sea surface temperatures have changed at all. They're going to look at atmospheric conditions. Meteorologists will assess changes in atmospheric conditions, including that wind shear that we talked about, the moisture levels in the atmosphere, and any atmospheric instability that they might see. If they happen to see, for example, a decrease in the wind shear and a subsequent increase in the moisture, you should be able to guess that those two things together mean you're going to have a much more conducive environment for the formation of tropical storms and hurricanes, which means you're probably going to revise your prediction if you made one and say maybe the hurricane season is going to turn out to be more active than we thought. They're also going to look at tropical weather systems, specifically the presence and the behavior of tropical disturbances, tropical waves, and low pressure systems. They will monitor those. They'll see if any of those have formed, where they're formed, how they progressed. And because they know that these systems can potentially develop into tropical storms and hurricanes if the other conditions are right. So they will take these things into account. Plus, they'll also factor in things like historical data, satellite data, all sorts of stuff. And if they need to, they will then revise their predictions, for better or for worse. So, as you can guess, all of this is a pretty complicated science that has to take a lot of different things into account. And most of those things that it does have to take into account are things that are constantly in flux. They're constantly changing. So, having said all that, as we barrel into the months of the season or barrel towards the months of the season that historically tend to be the most active, have those predictions changed since the ones we saw in April and May? And in a word, the answer is yes, they have. So in mid-August, the NOAA released updated predictions for the 2023 Atlantic hurricane season. And what those updated predictions did was they called for an increased likelihood of greater hurricane activity and what they called an above normal season. So the original outlook predicted in May gave about a 30% chance of having an abnormally active or an above normal season of activity. 30%. We've now got a few more months of data under our belts, and they have revised their prediction. They now believe that there is a 60% chance of an above normal season. So, what's the new prediction in terms of those storms, numbers of storms that we talked about earlier? Well, the new prediction is they're predicting for named storms. They're predicting between 14 and 21 named storms. They're predicting between 6 and 11 hurricanes. And then they're predicting between 2 and 5 major hurricanes. Now, if you remember what they predicted at the start, they said 14 to 21 named storms, 12 to 17 named storms. That has gone up to 14 to 21. So you see an increase in that number. Hurricanes back in May, they said between 5 and 9. Now they're saying between 6 and 11. So that number has gone up. And then major hurricanes in May, they said between 1 and 4. Now they're saying between 2 and 5. So they're predicting a more active season. Now, before we go on, one thing that we want to point out, we've talked about named storms, right? We've also talked about hurricanes and major hurricanes. And so someone might raise their hand and say, what's the difference between a hurricane and a major hurricane? Well, the terms hurricane and major hurricane, they refer to different categories of what they call tropical cyclones. That's the meteorological term for a storm. Um, Different categories of tropical cyclones based on their intensity. And what they're looking for, the thing that distinguishes between a hurricane and a major hurricane is the wind speed. So a hurricane is a tropical cyclone that has sustained wind speeds of at least 74 miles an hour. Now, when they talk about hurricanes, you will often hear them say category 1 or category 2, or they'll say cat 3, cat 4. God forbid they'll say cat 5. Those refer to the different increased bands of speed in what they call the Saffir-Simpson hurricane wind scale. So category 1 has to have a sustained speed between 74 and 95 miles an hour. Category 2, Category 2 is between 96 and 110. Category 3 is 111 to 129 miles an hour. Category 4 is 130 to 156 miles an hour. And then category 5, the big one, is 157 miles an hour and above. And remember, these are sustained wind speeds. I'm not exactly sure how they define sustained for these purposes, but it's not just, it hit 157 miles an hour for a second somewhere out there. Sustained wind speeds. So that's how they classify hurricanes. So a major hurricane is really just if it's a category 3, 4, or 5. That means hurricanes with sustained wind speeds of at least 111 miles per hour. So if you think about it, all major hurricanes are hurricanes, but not all hurricanes are major hurricanes. And the long and short of it, with respect to how they have altered their prediction, is that they're predicting that it's more likely than not that we're going to have one or more additional major hurricanes to worry about than they thought we would at the start of the season. So, as of mid-August, the Atlantic has seen 5 storms that have already reached tropical storm strength, with 1 hurricane already, although it was one that really didn't have any significant impact. Given the extra activity that they're predicting now, I think it is safe to say that September, October, November could be shaping up to be, maybe a busy final months of the hurricane season. So why did they change their predictions? What changed? Well, if you ask the meteorologists, they're going to give you a somewhat technical answer, and they're going to talk mainly about 2 things. They're going to talk about the ongoing presence of an El Nino weather system, and then they'll also talk about the existence of something that they call the warm phase of the Atlantic multi-decadal oscillation. Okay, what do those things mean? Well, let's decipher that. Let's simplify this a little bit. So, El Nino. El Nino is something you probably have heard about because they talk about it almost every year. They'll say El Nino. Sometimes they'll say La Nina, which is the kind of the corollary to it. Well, El Nino is the name for a climate phenomenon that is characterized by the warming of sea surface temperatures in the Pacific Ocean, the central and eastern equatorial Pacific Ocean. And it tends to have significant effects on global weather patterns, including having an impact on hurricane development all the way over in the Atlantic basin. Now, the interesting thing is what they've seen is that if you have an El Nino system, many times it doesn't make hurricanes more likely. It actually reduces hurricane formation. Now, how does it do this? Well, first of all, one of the significant impacts that an El Nino system has on hurricane development is it tends to result in increased vertical wind shear over the Atlantic. And remember, when we said that when you have higher amounts of wind shear where the wind is changing directions erratically and also changing speeds erratically, um, it will tend to make it harder for storms to form and strengthen, stay together and strengthen, and then eventually form those tropical storms and hurricanes. So many times El Nino will actually result in more wind shear, which makes it harder for those storms to form. Another thing that it tends to do is it tends to shift the main areas of thunderstorm activity eastward, away from the Atlantic hurricane development region. And what that results in is you get a drier and more stable set of atmospheric conditions over the Atlantic, which means it makes it harder for tropical cyclones to form and intensify. Then another thing that it does is it's often, even though we said it's associated with the warming of the Pacific Ocean, that can actually sometimes lead to cooler than average sea surface temperatures in the Atlantic and the Caribbean, the parts of the tropical Atlantic and the tropical Caribbean. And of course, as we said before, if you have cooler water, that's less energy for hurricane development, limiting the potential for storms to strengthen. So we just named three things that we said El Nino is often associated with these, which means you often get fewer tropical storms, fewer hurricanes. Yet the NOAA said, oh, we've got an El Nino system, and that means we're going to have more. Okay, so there has to be something else at play here. And this is really an illustration of the fact that weather, how weather develops is often a result of multiple factors working together or working in conjunction with each other. Now, by itself, El Nino does certain things that makes it harder for hurricanes to form. But there's something else that's happening at the same time, which is apparently blunting some of the traditional effects of El Nino and enhancing some of the effects that actually make it more likely for more storms to develop. And that thing is what they call this Atlantic multi-decadal oscillation thing. Okay, what is that? Okay, we'll call it AMO for short. Okay, so this AMO it's a climate pattern, first of all. And what it's characterized by fluctuations, that means up, or cycles of up and down, cycles of sea surface temperature in the northern Atlantic Ocean. Remember, the Atlantic Ocean is a very big body of water. You have the North Atlantic, and then you also have the South Atlantic, or the South or tropical Atlantic, over by the Caribbean. So this Atlantic multi-decadal oscillation thing is a climate pattern where you see sea temperatures going up, periods of warmer sea temperatures, and then periods of colder sea surface temperatures in the northern Atlantic. And it's called multi-decadal because it actually works on a time scale of several decades. So you'll get long periods of warmer sea surface temperatures, and then you'll have those followed by long periods of cooler sea temperatures. So it's not really a case where, you get 2 months of warm temperature and then, a couple months of cold. No, we're talking about periods of years where you have warmer seas in the North Atlantic. And so what the meteorologists are saying is that right now we are in a warm phase. We are in a warm phase of this Atlantic multi-decadal oscillation thing. And when you have this warm phase, the warm phase is associated with, again, higher than average sea surface temperatures in the North Atlantic. And so when you have warmer temperatures in the North Atlantic, then several things start to happen, which make meteorologists think are going to result in a more active Atlantic hurricane season. First of all, it's a simple fact that the sea surface temperatures are warmer. We've already said when you have warmer ocean water, that is the fuel that hurricanes and tropical storms need, first of all, to form, and then the fuel that they need to strengthen and keep getting stronger. And they have exactly that in the North Atlantic. Second thing that this does is it actually reduces the vertical wind shear. Remember, we said El Nino just by itself will give you more wind shear, which makes it harder for storms to form. But when you throw in this Atlantic oscillation thing alongside of it, it actually negates the effect of the El Nino and actually causes reduced wind shear over the Atlantic. And so when you have warm sea temperatures plus less wind shear, you're going to get more storms forming. And that's what the meteorologists think is going to result in us having now a more active hurricane season. So that's really the biggest thing here. We've said that there's all these multiple factors coming into play. If you had to pick one, if you had to pick one of these things that was most responsible for us having an active hurricane season, it would be the fact that we've got so much warm water in the oceans. That probably is going to end up being the biggest factor. And so that is what they're predicting. So now we have to ask the question, okay, we know this, so what do we do about this? Remember, if you've got stored fuel, if you are a professional who, you have to wear a lot of hats, we all know that, and maybe one of the hats is that you have to make sure that the fuel's taken care of, you have to make sure that it doesn't have any problems. You have to make sure that it is available and healthy and will do the job if you needed to, let's say, power emergency backup systems. Well, now you know that they're predicting we're probably going to get some hurricanes heading our way. So you've got right now maybe a few months to prepare for what could be some pretty serious situations. So the question is, what should you do to prepare from this point on? I mean, when it comes down to it, storm preparation for mission critical stored fuel, it's not a terribly complicated thing, but it is something that you need to do in advance. So if we were giving advice, what would we say that you needed to do right now before the storms came? Okay, so there are some things that someone in my position would recommend to someone in your position. First thing I would recommend is you need to make sure to check your stored fuel for the presence of water and the presence of microbial contamination. Checking for water can be as simple as taking a folding tank stick, putting some water paste on the end, and sticking your tank, as they say. That water paste will help you determine if you've got a visible water phase. If you've got a visible water phase, then there are certain things that you have to do about that. We would not recommend that you rely on the automated Veeder-Root systems to give you the final answer. Those are good for offering, supporting, a supporting picture, if you will. But Veeder-Roots can be affected by certain things like microbial contamination, first of all. They can be affected by changes in the density of the fuel. And when that happens, they can give you faulty readings. It's easiest and safest to just do it manually. So that's the first thing. We recommend you check your stored fuel tank for the presence of water and microbes. Second thing we recommend is if you find water, you got to get that water out of there. So if you have a detectable water phase, you need to get that pumped out. And there are several good reasons to do that, but the not the least of which is that any significant water presence, like free water phase in there, is going to vastly increase the chances that you're going to get a microbial contamination situation. Third thing that we would do is, if you haven't already done it at some point before, uh, do do some fuel testing. And what we mean by fuel testing, because there's a lot of different kinds of fuel tests that you can do. When we say get your fuel tested, um, first of all, have a microbe test done. We said before, check your tank for microbes. This is what we mean. Have a microbial test done. Um, Second kind of test that's usually good to do is a water and sediment test, because that is one of the tests listed on D975. And if it comes back as above spec, well, then you've got a problem that you need to remediate. Uh, any kind of fuel testing like this is going to give you the benefit, what we call the benefit of a clearly defined problem, because it's going to be objective evidence as to the condition of your fuel. And it could be an objective sign that this mission critical stored fuel, that you really need to have it work when one of these major hurricanes is bearing down on you. It's going to give you a really good objective picture as to the likelihood that that's going to happen or not. So do certain kinds of fuel testing. So if you do this kind of fuel testing, and you get the results back and they come back clean, well, now you've got confidence, or you have more confidence than before, that your fuel is going to be available to do what you need it to do during a hurricane event. So check for microbes, or test for microbes. Do a water and sediment test at the very least. Then, based on those results, you will know what you need, if you need to do anything else. The big thing, though, is do these things now. Do them now, so that if you need to take action, you will have time to take whatever action you need to do, and you won't be scrambling along with everybody else to get ready for this hurricane that happens to come. Now, there are groups that you can contact that will help you get this kind of testing done, because when I say do fuel testing, one of the things you probably think is, well, how do I do that? No, I don't know how to do that. Fair enough. There are groups that you can contact that can help you get this kind of thing done. But it's something you want to do now, before the storms are coming, because when that storm's coming, it's going to be too late if you're waiting until the news says that a storm's going to be here in 2 days and you're scrambling to prepare. And one of the reasons we say this is you're probably going to have other things to worry about for storm preparation other than taking care of the fuel. You're probably responsible for more things than that. So take care of your fuel now. If you know that they're saying, hey, there's a good chance we're going to have an above average season, take that as a warning. Check your fuel now and get any problems taken care of now rather than later. So that is going to be all for today's episode of the Fuel Pulse Show podcast. You can find information on everything that we talked about in the show notes. Once again, if you haven't already, feel free to subscribe to the show on your favorite podcast platform. Leave us a rating. Definitely leave us a rating, as it helps people to find us. And of course, tell your friends if you liked what you heard. So thank you again for joining us for today's episode. I am your host, Eric Bjornstad, your guide through the ever-changing world of fuel. I will see you next time on the next episode of the Fuel Pulse Show podcast.